Hey, how's it going?
Hey, everybody.
Hey,
Hey, Javier over here. and
Jeremy.
Joe over there. Hello, hello. And because I have a crappy computer, I won't be able to show my face too much.
Oh, hello.
Yeah. But we got over here Mr. Joe and Mr. Jeremy. You know everybody, Joe. Joe, say hello.
Hi.
And then Jeremy is here. Jeremy is the owner of all this cool
Hey,
stuff. And he joined
Javier's
us.
been helping me a lot with all the stuff that I've been collecting over the last roughly 10 years.
Great. So that's why we invite you. So you can tell us more about this because I've been showing some of your stuff, but it's cool that we hear from the owner of the stuff. So I'm gonna put some gloves on. Oh God, this is too small, man. Or my hands are getting bigger. And I think my hands are getting bigger. I don't know. So anyway, I'm gonna open this machine and I'm gonna show what we're gonna do. So tonight, what we're gonna do is, and Joe is pretty happy that I'm doing this because, oh, look at Mr. Joe. Yes, sir. I'm gonna take a few programs before I did an upgrade to my TransWarp, and I added some heat sinks.
Oh, you did? So that came in the shipment, and you're able to. I know
in the mail today, yeah, exactly. And Jeremy asked me to do the same thing to his machine. So that's what I'm going to do tonight.
It sounds like a great idea. Yeah.
Isn't it? Yeah, well, ask Joe. Joe, what do you think?
I think it's a great idea.
Yeah.
Absolutely. So Javier did his experiments with adding. Here, I'll show you on Benchcam here. He did his experiments with adding heat sinks to his TransWarp, and he's like, it's cooler and great. I'm like, well, my TransWarp only does like 13.5 megahertz.
Yep.
Oh,
well,
really?
I heat sink the crap out of it. Now I can get it to 17.
Oh, really? So
Yep.
by the heat sinks alone will change how fast it can go.
Oh, heck yeah. Yep.
I think I realized.
That's Javier's going to show you the process while I mess around with mine.
Wow, this is amazing.
So this is Jeremy's machine, and Jeremy has an amazing machine over here. I showed the last time. The only issue with this machine is, I mean, it's not an issue, but the issue for me is that it's a little bit loud because it has two big, and when I say big, I mean big fans. This one is not one, and then there's another one here.
Yeah, we need to fix that, and we have a process for that.
So
you already have the heat sinks, and or you're working on those too.
Oh yeah, Joe has he already did it.
Yep.
So you already did it.
Yep.
And so you took larger ones and were able to kind of cut them to fit on the.
Well, there's a kit you can get of just a whole bunch of tiny ones.
Oh wow.
Yep. And it comes with this thermal glue, which is kind of like a silastic type of glue. And you can put it on the heat sink, squish it down, and wait about 24 hours, and then the heat sinks just stick onto the chips. And it cools the chips down.
Yep. And I guess as long as it's smaller than the chip, then if it's a pre-made size, it'll work.
Yep. That's exactly it. And so I put, following Javier's advice, I put the heat sinks on all of the PAL gal chips here, which are the ones that get really hot. And also on the underside of the cache board. I'll take that off and show everybody.
Oh, that'd be interesting.
Yep.
I'm gonna do that on yours.
I'm leaning forward like I'd be able to see it there. Oh, I see. Okay, so that's the front of the cache board, I guess.
Yep, and so it flips the other way, and there's enough room in between the sockets here for those heat sinks to fit. Now it doesn't get a lot of airflow in there. But it helps because it's a heat sink. It's just a big thermal mass to suck heat out of the thing. Suck heat? Is that a term? Suck heat. Anyway, hi, my name's Joe, and I didn't learn how to speak in high school.
All righty, so here we go, guys. This is Jeremy's beautiful TransWarp, and just let
I remember when I got that card probably 6-7 years ago, and like it was I think it was the biggest purchase by far. You know, of like one
For sure.
whatever. But you know, it's like, oh my god! But I could see the importance of it. So,
But you know what? Your machine is really good because it's at 16 megahertz already, and it works well. So
wow,
as you guys can see, look at it. It's nice. I took out the fan out of it, and it has 4 things stuck with some tape to actually the gals
They're just
directly.
taped on the gals.
Yeah.
that was what was holding the fan, I guess, right? Like above those. Oh,
Yeah.
so the fan sat above all the gals, I guess. Those 6.
Yeah.
Yeah. So I'm taking it out.
So basically, instead of like getting rid of heat, they're just sitting there insulating airflow.
Yep.
Oh, that's weird.
Yeah.
So the other thing I was telling Javier is that it would require at least 2 additional slots, like one just for the fan's physical mass, and then at least one more to give it any ventilation. You know, so you're basically
Right.
3 slots just to use the TransWarp card with it. You know, that kind of thing. So
Right. Yeah. So that's the issue that I'm not that
incredible
crazy about it.
with these different cards. So we're going to use up like 3 slots in this. So, but this should make it possible to do less.
Yeah. Now I'm gonna take out those TWGS stickers. Hopefully, I'll be able to put them on the side or something like that. Because I'm gonna put the heat sinks, of course, on top of them. So they really,
They're little stickers that say for GS or something.
yeah. I mean, I don't know. I put them on the side like this. So I'm thinking about doing the same thing.
Oh, cool. That's
What
what
do you do, Joe, on yours?
successful model. So you
What's
already
that?
know it works. So.
The little text, the little papers with text that says TWGS 2B 2A or something like that.
Yeah.
What do you do with those?
I just removed them.
Okay.
Mine is my TransWarp is a prototype remake model, so it's not
Okay.
original. So I literally do not care what happens to those stickers.
Okay.
Oh,
It's not. I'm not trying to preserve it or anything like that. So I just yanked them off.
Well, I think these ones are not original.
Take them out and put them back in. It doesn't matter. So
I think these are
Joe,
from.
do you go on eBay a lot to collect or look for cards that you want to preserve, or not really?
I don't personally.
Yeah.
I'm the kind that like I just wait for things to randomly come across my path, because if I were to go on eBay to try to buy things, I would never leave and I would end up poor. So yeah.
Yeah.
But it cut out for a second. But you said if you went in, it would be very expensive, I guess, to just go.
No, yeah, I was just saying if I were to go on eBay to try to buy stuff, I would never leave eBay and I would end up poor.
Yep.
And it's like whenever you go on, it's like maximum price, and when you look a week later, you're like, oh, I could have had this for half the price. So
Yeah.
it's always the wrong time to look for something.
Mhm.
But
All
Joe,
right.
you UGSs or something, right? Or at least.
Let's see what's going on with the people. Hey, Gal Chips, that overheat 2WS is being overclocked. That's Herbert, yeah.
Herb.
Original solution. Hi, Herb. It's a paste fan over the cooldown, yeah, but not as hefty. Yeah, exactly. So it's a good idea. Yeah, this is a very good idea. But yeah, the heat sinks are a better idea. And I already proved that they really keep them really cool. So
Yeah, that looks amazing.
yeah.
And then at the minimum, you could turn down the fan speed, right, which would make it softer, or maybe not even
Quiet.
need it.
Exactly.
Like,
So I already took out all this. Hold on. I already took all this, and I'm gonna just put a little bit of alcohol to clean it in some wipes.
Alcohol.
Alcohol. I remember at K-Fest once we began to clean everything with alcohol, and then the whole room was smelling of alcohol, and everybody was like, "Oh man," you know.
Everybody knows where the cool kids' room is.
That's right.
Joe, did you also go this year to K-Fest?
I did not go in person. No, I attended remotely. I have to be careful about conferences and stuff that I attend, and my exposure to we'll call it environmental toxins.
Yeah.
So I attended remotely though.
Yeah, Javier and I think are pretty careful too. But
yeah, I was very, very worried when I went to K-Fest, honestly, but thankfully it was really very, very safe. People were very nice and didn't have any issues about.
Yeah,
yeah, because I'd love to go. I mean, I've never gotten to go. But,
yeah, you got to go.
Yeah. So I'm just I'm doubling down on my process. I have actually put a fan over top my heat sinks.
Oh, you already did that, Lindsay?
Yeah. And so I screwed the heats. I just used some small zinc screws to screw them into the little heat sinks.
Oh.
If anybody's watching, you're going to do this. Don't over torque those because you can actually pull the heat sink off the chip.
Oh wow!
Because, the glue does not have a lot of how can we say? It doesn't have a lot of stress bearing capability.
Okay.
And these don't have to be literally screwed on too tight, just tight enough so they don't rattle.
Okay.
Yeah.
So instead of bearing into the heatsink, it just pulls the heatsink off.
Yeah. It just that actually you can't really see it. Here, let me change. This one right here, this one on the corner, I had to re-glue this evening because when I went to remove the previous fan I had on here, which it was noisy and wasn't working very well, it was proof of concept fan. I actually accidentally yanked the whole this one little heatsink off. So I had to yeah.
Oh wow!
You can also see I didn't put a screw in there just in case. Now what happens if you get one screw that's in good, and this rack's at a kind of an angle if it's not perfectly even. When you torque down this, it acts like a vise. It'll bring it'll pull the heat sink on the one corner up, and it'll just pop it right off of there. So you got to be careful with that.
Oh wow! So
you can almost see it too. There's a little gap there in here where the heat sinks aren't level. So what happens? See, I can kind of push it together there. So when I screw this down, instead of it pulling the fan down, it pulls the heatsink up and yanks it off.
Oh God!
Oh,
so there's no way to really get it.
Yeah.
Yeah. Oh wow!
But anyway, here I can show you what I was doing before. Is this fan has a clip on it? That is a blurry mess. You can't see squat.
Okay.
I got two of them. So this fan has a little clip on it. It's got a little like retention clip thingy doodle.
Mm-hmm.
That doesn't really like fit. Can we be in focus, please? That doesn't really fit into the Apple II GS's plug. So I was just using it's a scalpel.
Oh, I see. You can sort of sand it down.
Yeah, I just kind of shaved it off. So
I see what you mean.
Correctly. Yeah.
I guess it's the two prongs, the back of the motherboard. That's the one you're using to power.
Exactly. Yep.
It's
The
like
little 12-volt connector. Exactly.
Shooting things won't go flush against the case. I guess. That's interesting. Huh.
That's pretty good.
Put it in. Yeah.
All right. So I'm going to start doing it. And
Javier's going to show the process of actually putting on the heat sinks, right?
Yeah. Cool. So the only difference that I'm going to have with your heat sinks, Joe, is that I'm going to put them up, facing upwards.
Upwards, so that it'll get a draft across it. Yeah.
Exactly. So the air doesn't go like this, but goes like that.
I got a lot of flack on the internet when I showed everybody I did it my way. Like, you put it in the wrong direction. I'm like, it won't matter. It doesn't matter.
Matter.
So
shut up.
Hush. But no, it's okay. Yeah, it's that way.
And what do you? And I know Javier and I were talking about the noise on the power supply itself. Maybe that we could reduce.
Yeah.
Javier, you weren't sure which thing is louder, which fan or whatever. But, right?
Yeah. The power supply fan is really loud. These little guys are not. They barely make any noise at all.
Yeah.
But the power supply fan, we have a process we're going to try to see if it'll do it.
Yeah, I don't even know what the process is to slow down a fan. I'm not even sure how you would.
That's exactly what it is.
That's what we're gonna do. Yeah.
You put I'm trying not to how can I put it? I'm trying not to spoil the secret.
That's all right.
I'm trying to generate more people to want to wait to watch later. But basically, we put a component in line with the fan, which will slow the fan down.
Component
Right.
like so it'll be like a box fan's medium off.
Mhm.
Not exactly, but it'll be static. It'll have one value that it runs at. That'll slow it down. It's basically a resistor.
Wow.
Okay. So let's
Like-
see.
So I aligned them
Yeah.
really nicely, and I got OCD just like Joe. So let me show you. I aligned them, and then I pushed them at the end.
Oh wow, look at that.
So still, they're not that. No, yeah, they're pretty straight. Yeah, I gotta straighten up a little bit, but yeah, it's almost there.
Joe, do you think that the TransWarp uses so much power that the thing that allowed Javier to fix it was switching the power supply from a stock GS one to
Oh yeah,
the
yeah. The
Like-
TransWarp, the faster you do it, the more power it consumes. That's generally the general concept of how all switching transistor systems work. The faster they are, the more heat they generate. And I'm not going to get into the theory of why that is because I don't know it. But basically, yeah. And so if you overload the power supply, the stock power supply, it can have problems supplying the current level required. Not to the point to where it goes into current trip, but to the point to where the power going to the machine gets noisy and messy, or you'll get a voltage dip, which then the chips won't operate properly. So by upgrading the power supply, it solves the problem.
Yeah, I see. Because for years, the reason I couldn't use that 2GS because I had an older TFFA card, not the 3000 one, and it would try to load GSOS 6.0.1, and sometimes it would make it all the way through the bar to the main screen. But if it made, no matter what happened, within about inside of 2 minutes, it would go into what looked like a machine language screen that you couldn't get out of with white text. And I couldn't figure out what it was. So I was thinking maybe it's the power supply. I don't know.
Yeah, it very well could have been. Because what happened, the machine runs hotter and hotter. And gosh, you're pulling out memories about how this crap works from like 20 years ago.
Yeah, because I tried to sort of troubleshoot the limited knowledge I had of like what else it might be, and I just couldn't find it. So for a time I had that. You probably know that bug power supply from Stephen Buggy, but that didn't really fix it. But apparently, since Javier's been using the new one, that
just works. Yeah,
like a gal on the RAM card, right?
I just did that. Oh, just for you guys to know, Henry, I was not aware of this, and I'll show it in a minute. Let me just finish this. I didn't know that Henry has a gal for the RAM card, so it runs better or something like that with the TransWarp.
Oh, really?
I was not aware of that, and of course this gal is for the
Javier. I sent you that article I saw online that where some guy was talking about it, and he said he was getting this checkerboard screen, and he finally realized that if you mismatch the ROM 1 to a ROM 3, or the opposite, that like although it was never in the formal literature, like there actually was a difference or something like that. So I don't know if that, but Joe, it sounds like you think it was probably just the draw of all the cards that was making it go into that machine language.
Oh yeah. It's a weird inverse problem. So the faster a chip runs, the more electricity it wants, the more juice it wants.
Mm-hmm.
But the faster, because it wants more juice, it draws more current from the power supply, which can cause a voltage drop, which then will cause the chips to not work right because they want more juice. It's this weird feedback loop. So if you install a better power supply that can provide more current, the voltage will stay stable. Instead of dropping at 4.8, 4.7, 4, and start dropping down, it'll stay right at 5, which means the faster you run the chip, it's still got the power it needs, and it makes it more stable.
Yeah.
When the chip gets less power, it can get into what's called its avalanche area. Instead of snapping perfectly to 1 or 0, the transistors can kind of float in the middle, and then they don't have discrete values, and that was causing your crashes and things.
And probably if that even happens for a second, then it turned off. I found, like, even when I did the control open Apple reset, even that it didn't respond to. So I had to literally turn it off and wait.
Yeah,
and then you have to wait like a couple minutes before you turn it on, because I guess the GS, it's not like a modern computer where you can turn it off.
Oh yeah. And you know, those problems could be heat in the power supply could have been causing it to just not perform well and not providing enough current, so you had to shut it down to cool it off. Also, it's not just like the CPU that can be affected by those power draw issues. It can be any of the chips in the machine. So if you do a quick reset, you could still the memory could still have garbage in it.
Oh.
So you go to boot it again and it doesn't boot right. There's like 1,000 different things there.
But Javier, it's been staying on, like, you've been able to keep it on for like some period of minutes or like without it going into that.
No problems. But as I just show you, I put that gal that you sent me.
Oh, cool.
There it is. That's the gal. So it's supposed to be now good. I gotta check it. So we're gonna install it and make it run when I finish. Oh well, no, because we gotta wait. Oh, how much do we gotta wait, Joe, for this to work?
Yes. You have to wait about 24 hours.
Oh, okay.
Yeah. It doesn't
be online a while, I guess. Okay.
You can watch it. You can see it work on mine. See, it's working.
Wow, that is,
you're gonna be like that. You're 17.
Wow.
I'm sorry. Did you ask me a question? I was talking.
Yeah, that if you were running at 17.
Yeah. Look at that, man. It's just like yeah, baby, yeah, 3D or something. I don't know. I don't play video games. I'm bad.
No accelerator or zip one or something. It just wouldn't be anywhere near like that. What we're seeing, I guess.
No, Zip GS can't get this fast.
Like, I don't know if you guys also ever use the Zip, but
no, I've never used the Zip GS. I've understand they're much rarer.
But I think they're not as good, right? They're sort of.
I believe they have a reputation as being more stable, but they don't. You can't clock them as high.
Oh, I see.
So,
as I remember, with the TransWarp, it's like in the ROM itself that you could select the speed. But is that how you're deciding how high to clock it? Like, you go into that menu and you just go up and up and up?
Oh, yes and no. So the TransWarp GS has from the factory, it had a soldered in oscillator, which set its speed. But you could replace the oscillator with faster ones to increase the speed further and further and further, right? I have my TransWarp has a Ultimate Micro scalable oscillator on it. It has dip switches.
Oh, cool.
That change the clock speed in increments of 0.25 megahertz. So I keep ratcheting it up until the machine becomes unstable. Then I bring it back a notch.
Mm-hmm.
So yeah. So, and that's the thing is, like with the heat sinks and everything on this and the fan on it, like 17 megahertz. The thing originally came. What did it ship as, Javier? Like 7.7.
Yeah.
It's more than
7. Oh, really?
It's insanely fast. This is better than most Macs of the time. It is just the bomb. Now it's great.
Wow.
Yeah.
Wow. It sounds like your GS is amazing.
Well. Yes, I'll take credit for that. Sure.
Now it is.
Yeah. Herb had a question. So what you're saying is I need more power so I can be more stable. Generally, yes. John, it is a good idea to make sure your power supply is super stable and high quality to just at the very least just to eliminate variables. Because what happens if you've got a TransWarp with no heat sinks and no fans and stuff,
Mhm.
using old gals, and you've got an old power supply, and you've got, I don't know, some sketchy third-party RAM card in it. You've got all these variables. Why is it unstable? Could be anything. Could be all of them. Could be none of them. It could be sunspots. Who knows? What you want to do is you want to eliminate those variables. In addition, having John, it's still better than the current max. Yes. In addition, having the stable power supply just makes the whole machine that much better. It just makes it. You're not going to be worrying about it exploding or overheating or doing anything like that. Yeah.
So that newer power supply, does it put out more power, or it's the same amount, but it's a stable current?
It's a little bit of both. So it provides the same voltage, but it can provide more current. The off-the-shelf power supply can supply something like 3 amps max, 3 amps of current max, whereas this new one can provide something like 6 or 7. So if you look right here at the amp meter on my supply right now, if I can get it to,
I see. It looks so much like mine. Okay, oh wow.
So this is a super fancy one. As you can see, it's running at 3 amps right now. So if this were running on a stock power supply, the power supply would be pushed to the absolute maximum. Absolute maximum.
I see.
Pushed to
by
so you're, and if the power supply is older, it's got bad or old caps. If it hasn't been repaired or replaced, it's been worn out because blah 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 blah, heat and all the blah blah blah. So yeah, it's a factor just eliminating those variables, right?
Because I guess these machines were just never built with the idea that you would use them 30 years later.
Yeah.
So, but Joe, so what other cards do you have in yours? I'm always curious. It looks like you have an Ethernet card.
Yeah, so I have the Ethernet card in here, the TransWarp, obviously. I've got a compact flash for Apple II.
Okay.
CW RAM, an 8 meg CW RAM card. Yep, max to the max.
Oh, it cut out the thing, but something you're saying, right?
Oh yeah, compact flash for Apple II, a CFFA 3000, and then here's an 8 meg CW RAM card. I also have a microdrive turbo, but it's being weird at any speed, so I removed it.
Oh, you had it in with the CFFA, or
yes,
or the other? Or,
yeah, I had them in both in there. Maybe they don't like each other. I don't know. So, but the CFFA has always worked great, if just a hair slow, and the microdrive turbo has been being weird. It's
really
itself. Yeah,
so Joe, sorry, I'm gonna put it like this. Is that okay, Joe?
Yeah, in that case, I don't think it really matters because there's no airflow under there anyway. It's just about adding thermal mass to keep the average temperature down.
Yeah, great. Thanks. Sorry.
Javier, that looks really good. Wow, that looks amazing.
Yep.
So you're putting it on both sides. Wow.
Yep.
And it's going fast too. So okay, so you're saying, oh yeah, so it has the 8 meg RAM card.
Yep.
I'm probably more familiar with it.
Yeah, I can slide it over here and go super zoom, super zoom, super zoom.
Is that on the left side of it, or that's something else? I can't see it. Oh no, it's just a very big RAM card that goes all the way, or relatively big. Because
yep.
I see. So you have that. You have the CFFA. Wow. So you really have really cool.
Yeah. My GS is pretty maxed out.
Good.
Pretty maxed out. I mean, and it's really telling too that. So there it is with the fan on it. I put my finger on there, and it's barely warmer than room temperature.
Oh, that's amazing! Oh, wow,
keeps these things insanely cool. At this point, going above 17 megahertz is probably just honestly a limitation of the CPU itself. I'm probably actually crashing the CPU because it's rated for 14. So at this point we're way overclocking the CPU itself. And then that's probably our limiting factor. It's not even hot. Like it's no warmer than these. It doesn't even have a heatsink on it. So putting a heatsink on the CPU really doesn't do anything.
I see it. So it wouldn't allow it to go any faster or
yeah, because it's not going to
stay any more stable.
The heat is no longer being a problem in that case. It's actually interesting how the physics of the heat work. When chips get hot, the electrons wiggle faster is the best way to explain it. And so they can, instead of staying in their silicon channels as they're traveling through the chip, they'll fly off in weird directions and cause voltage transients. And that's what causes the instability for hot chips, generally speaking.
And usually whenever there's even a momentary interruption, that's it, right? Like you have to restart everything. Like it's not like
it screws up the machine's entire state, and it doesn't know where it is anymore. And so everything's operating off of false assumptions about what the previous state of the transistors was, and then it just doesn't work right.
So is that thing that looks like machine language actually machine language, or it's just some other thing it goes into? It just says,
it could be machine language. I don't know what your screen actually was, but it was probably dumping to the monitor, which is oh my God, I've crashed. I don't know what to do. Here's the state of the computer. Fix me.
Yeah.
It's basically what it is. It's a typical Apple II thing. When it crashes, it dumps to the monitor so you can debug it. Assuming that it was a program error, effectively. Yeah. Yeah,
because it would go right from the desktop of GSOS like within 30 seconds, like any attempt to do anything, and it would just go into that to open anything that's going to the machine learning. Yeah.
Yep.
All right, so I'm done with this, guys. But unfortunately, you're right. I'm gonna have to wait until tomorrow to test it, because I gotta wait 24 hours.
That's fine. It's another stream.
Yeah, exactly.
Shaky cam. Sorry, I'm trying to get my camera to work correctly.
Good. No worries.
Can't get the mount to work.
Oh, you have it on a tripod or something? Like
kinda, sorta, yeah.
It's the one thing.
Like tripod is a very loose term in this sense.
Okay, maybe it's not exactly that. Right.
10.
So do you have you have a whole museum, so you must have like one of every Apple and other non-Apple. I guess.
I have many items, not all. I can't get it to work correctly. Stand by, it's bothering the crap out of me. I'll move it this way. There we go.
Yeah, now I can.
But yeah, Joe's Computer Museum. So I'll give you all the quick dime tour. There it is. It's back there.
Yeah.
It is all set up behind you. Oh, that's interesting.
Yeah.
So, but your favorite is the GS, right? At least of the Apple II.
The Apple II in general. Yeah. The Apple IIe, an enhanced Apple IIe like this one right here is my #1 favorite, because they'll run almost everything and they will run forever. As long as you keep a good power supply in it, the thing will literally run forever and never die. I have, interesting story, this same machine, but before I upgraded the power supply in it. So original power supply.
Okay.
Original hardware and everything. I was working on testing something for Henry Corbis, Reactive Micro. And I put the card in there, and the card had shifted slightly to the one side and shorted out to the card next to it.
Ooh.
It drew so much current that it caused the lead on one of the chips to glow bright orange.
Oh my God.
Killed the card. Apple II, right here, perfectly fine. Still works perfectly.
Wow.
The damn things are indestructible. You cannot break. If you break an Apple IIe like this, you dropped it off a building. Like, you can't break them. This is my original Apple IIe that I got in 1994. The only thing that has ever broken in this was the keyboarding. Actually, no, I take that back. The keyboard encoder in that is fine. It's just removed. I use this to test my keyboard encoders before I ship. The thing is a tank. It works. It just works. I can't break it. I've shorted it out. I've blown up cards in it. I've blown up a stupid serial card in the thing. I've screwed around when I was much younger, I screwed around with the joystick port and caused it to go into a power trip. All different types of stuff. I plugged in a Disc 2 card and had I did the offset pin trick, except in a way that didn't blow up the disk drive. Right. But I can't break it. I can't break this thing. I can't. So
the enhanced in particular, you think is the strongest of all the Apple IIes, even the 2 enhanced or something.
Yeah, you can't. And here exactly. Lemon Herb, our friend from up north, says James Littlejohn found a 2E buried in the ground. He dug it up, cleaned it up, flipped the switch, and beep, and turned on and ran.
Because if you think of like the early Apple IIs seem to be like sort of rotting and sort of they just decomposing just looking at, and then when you go past the 2E to the 2GS, like it has instability. So it's like the high point. If you imagine it like a curve with the 2E enhanced at the, as you know, even though now the percent difference in number of years between a 2 and a 2E isn't that much, but it seems like it's so much more sturdy, you know, decades later than I guess it's chips on the 2, you know, at 1 million RAM too, you know, and things like that. You know, was it that? Or?
Yeah, a lot of that stability curve is the Apple IIe, and a little to more to the extent the Apple II and Apple II Plus before it are utterly uncomplicated machines.
Oh, they're uncomplicated. Okay.
They're not. It's like 1/4 computer and 3/4 gigantic messy state machine to make video. That's it. That's all it is. It's not complicated at all. It's a very simple computer. If you subtract out the video generation of the machine, it's a chip, it's a CPU, a couple of chips to do memory timing, the memory, and a ROM, and that's it. Like that's all there is to it. There's nothing complicated about it at all. When you go to the 2GS, what they did is they took this entire board this big and shrinked it down to a chip that size.
Yeah.
Oh wow! Is that the thing that's on the 2E card for Macintosh?
Exactly. This is the Mega 2 or Gemini chip. It's basically an Apple IIe on a chip.
Oh wow!
And this part again of the 2GS, rock solid. If you run a 2GS like an Apple IIe, it'll just work. It'll work forever. It'll never have a problem. It's when you do all of the acceleration or the advanced stuff that you start to have some of those little glitchinesses because you're ramping up the clock speeds and you're dealing with all of this extra abstraction hardware to connect, I don't know how to put it, to connect this Apple II on a chip to this bigger 16-bit machine that's wrapped around it.
Oh, right. And so when you said using it like a 2E, it would mean like using it in only
you just like boot into
to
DOS or play like a pinball construction set, it'll be just as reliable as a 2E.
Really? Oh, that's so interesting.
It'll just whoop. It just works.
On your 2E, do you have like an LC2 on top of it? I can't tell what that is behind. But...
Oh no, that's the lid to the 2GS.
Oh, okay. It looked like you know the pizza box LC2 or something.
Yeah. No. I got an LC2 back here.
Javier, how you doing?
All right, so this is it. I got your
right. Yeah.
Nice.
Speaking of LC2, I got something to show Javier.
Show me.
I gotta find
everything.
File here somewhere.
Okay.
Oh, I can't show it to you because it's in a box upstairs waiting to go to you. Never mind. There it is. Send it right back out. So I
had that kind of curve in the disk drive. Doesn't that mean it's usually a Performa instead of an LC? Like that kind of round.
Yeah, mine's technically a Performa 410, but it's an LC2.
I always notice like these little details about, you know, like even though they're kind of the same.
Yeah.
But anyway.
Yeah, it's a Performa. I call it an LC2 because it is. It's just it has a different case and different badge name on it.
And probably the LC2 or the LC were about as equivalent a Mac as you could get to the 2GS, both when it was manufactured and sort of like sort of. I mean, if they had not, you know, for political reasons, stopped. You think everything would have converged pretty soon anyway? That things would have gotten too complex to have an open architecture thing for. I mean, I always wonder that. Like, would it have been a different trajectory?
What if?
I mean, I always wanted to see the ROM 4, of course, but like, I don't know, like, where else it might go, you know? Like,
yeah. I really do think the 2GS could have been a great continuation of the Apple II line. And when you think about, like, I'm abstracting it way over the top, and both Ron and Herbert have great points about the talk this year at Kansas Fest about the Mega 2, but I'm abstracting the heck out of it. the Mega 2 and the way the Apple II, the GS works is kind of, you can kind of think about it like a newer 90s DOS machine. You've got this really basic old school at the core of these old DOS machines, these old, MS-DOS Intel machines. You've got an IBM PC, a 5150, a little 4 megahertz machine at the core of it. And then it's got all these layers you can switch into to get you more of the functionality, but the base of it is still that old machine. In the way, the GS is the same way. And the GS was a great leap to be able to step outside of the Apple II's core, provide all these new features like the super high-res graphics, high-speed bus access, things like that.
And like the Ensoniq sound level.
The awesome Ensoniq sound chip, sound chip, and all of that stuff, but still have access to, at any time, and a click of a button, and better than the way the DOS machines did it by a large margin, the ability to just jump right back to old Apple II software and just run it. I mean, like, think about it. If you try to run a DOS application under Windows, like, you've got to have all this like funkiness to like support the drivers for DOS and do this junk and the DOS virtual machines and PIF files and crap. The Apple II GS, you just go click, click, and it will run an old DOS game, an old DOS 3.3 game. It'll be like, okay.
And if you
GS is still loaded and running in the background. It doesn't care because the DOS or ProDOS has its tiny little 64K shadow RAM that it just runs inside, and it doesn't know about the outside world. It doesn't need to know about the outside world. It just works.
Oh, that's interesting.
So,
but once you go into an 8-bit thing, like a program, how I never could see how you'd get back to the GSOS without turning it, just totally resetting it. Would there be a command that you could just go back onto your CFFA card and reload the?
It depends on the operating system you're using. If you're using like one of the ProDOS operating systems, one of the newer ProDOS 8s, or you're just launching it from GSOS, it has a command called BYE, BYE. If you type BYE, it will exit that session and dump out to the previous session, and it'll drop you back into GSOS.
Oh, wow.
Yeah.
Oh, that's interesting. Wow.
DOS 3.3 won't do that. But, yeah.
So anyway, look at this, guys. And Joe, this is nothing for you, but you know this already, but this is his fan.
Yeah.
Can you hear it?
Yeah, launching out of a cannon into the sun. Got it.
Javier, that's the fan from the TransWarp card, right?
Correct.
Okay.
And you can hear the sound.
Noisy.
Really noisy.
Yep.
So I'm gonna put 100. What do we call it? 100 hertz or 100 ohms?
Ohm.
Yeah, 100 ohm.
That's a metric.
Yeah.
Power, I guess, or an amount of power.
Yeah, something like that.
Ohm is the measurement of resistance.
Resistor, exactly. Thank you, sir. And I'm gonna connect it in between the red.
Yep, put it on the power line. You
know,
can't put it on the power line, but I wouldn't.
And well, it should work, but it's not. Oh, because I didn't connect it. Duh.
But Javier, right now you're just trying to test the fan, like totally disconnected from the machine. You mean just to?
Yeah, it is. Look at the fan. Can you hear it?
No. Can you, Joe? No, I can't.
Can't hear a thing.
There it is.
Because
running. I put, as you can see, it's in between. It's still
down below the audible frequency. The harmonic of the fans hitting the air is below the frequency you can hear. So you've just slowed it down. And you
really soft.
Slightly smaller resistors. You could go to like a 75, then a 50, and you can continuously reduce the resistors a little bit until you just hear that whine, and then crank it up a little so you can get the maximum airflow before you hear it.
So how did you do that? How did you like?
You just shoved it in the line. You just wired it in. You just stripped the wires and.
Oh wow!
It's magic.
Ron, I will look and listen as much as I want.
That's amazing.
So I'm gonna do the same thing to. Oh, it's hot. I'm gonna do the same thing.
Resistor's hot.
Yeah.
What's the current rating on that?
100.
No, the current rating on the fan.
Oh, on the fan. Oh.
Yeah.
It's DC 12 volts, 24 amps.
24
Point,
amps.
point 24.
0.24. So multiply 12 times 0.24.
Mm-hmm. Hold on. Oops.
So basically 12 divided by 4.
And that would give you what? The
Watts. I'll give you the watts.
watts.
We're doing math.
12 divided what? 24?
12 times 0.24.
50.
Not
So
divided. Times.
Huh?
Times 0.24.
Oh.
It's not a 50-watt fan, that's for sure.
2.88?
Right. So what's happening is that resistor
Uh-huh.
is dissipating a maximum.
Okay.
Maximum. Now we would add the resistance of the resistor back in, but you're dissipating maximum of 2.8 watts through that resistor.
Okay.
That's not a 2.8 watt resistor, is it?
No, I don't think so.
Quarter watt resistor.
Yeah.
Now how can I put it? The ohm value of the resistor goes into effect there, obviously. So basically, you would take that 2.88 and divide it by 100.
Okay.
And what do you get? 0.28.
Mike cut out. What you're saying? You divide something by 100 and then
0.288.
Yes.
0.0.
So I'm doing the math wrong, but basically the reason why that resistor is getting hot is because you're putting too much current through it.
Okay.
So what you would need is you would either need a higher current resistor,
Okay.
or you can put multiple in parallel. And what it'll do is the current will go through all three at the same time, but you're dividing the current amongst all three of them.
So three
So
like that?
If you were to put 2 or 3 of them in parallel,
Okay.
not in series, not hooked to end,
No.
all three connector, all
Like
three
bundled, yeah.
on one and all three on the other side, so they're all together in a bundle. You're dividing the current amongst all three of the resistors while keeping the resistance value the same.
Wow, that's
It'll
real
go way down. Yep.
Okay. So let me 3, you say?
Yep. Sure. Why not?
Oh, Javier, you can do this in real time. It sounded like a whole project.
Yep.
So by doing it in parallel, it's like you take away the problem, but you wind up with the same
You're
power.
taking the same amount
the
of
other
current,
end.
dividing it by 3 resistors instead of just 1.
I'm learning
So it
something
makes it
today.
cool.
Good. That's why I call the big guns.
Where are all these things? This is amazing.
That's why I call my friend Joe, because I don't know these things.
Did you learn this by like trial and error or like?
Learning.
Yeah.
Educated myself.
Educated?
Wow, it's amazing.
Like
Well,
that, Joe?
I will look at whatever I want
It says
with your eyes.
run something.
Here we go. We match, Ron.
Let me see. It keeps cutting up. I should come back and say.
All right, here we go.
Oh, that's
Also, if you look at my glasses with them upside down, they look angry.
true. That's like an innovative emoji in real life.
Right.
Different feeling.
One of my followers, Exodium, sent me the big eyeballs as a joke, and so I immediately put them on my glasses and made them a prop.
That's cool.
A 100-watt resistor, Rudy. The 100-watt resistor would be bigger than the computer.
They're
But okay.
they're still a little bit hot, but they're less hot. Yeah.
Yep. I'm trying to figure out the actual wattage dissipation through that. So it's 3 watts. So you're trying to do a maximum of 3 watts, but you're dissipating. It has to do with the voltage drop. Calculate resistor power dissipation. Here we go. There's a calculator that tells you. Multiply the square of the current with the individual resistances. The square of the current. So it's 2.88 times 2.88. So 8.29 with the times 100.
Mm-hmm.
Divide the voltage by the total resistance. Yeah. Well, we already know that. So the voltage by the resistance. Okay, so that's 12 divided by 100. So it's 0.12. But it's a quarter watt resistor. Shouldn't be getting hot at 0.12. It might get a little warm to the touch, but not hot.
Like, what uses the most power? Would you say, like, or offhand, can you think of cards that use it anywhere near that much, or in the GS, or no? Like,
what? No, yeah. The of anything you put in the GS, the thing that's going to ever use the most current is a TransWarp or Zip GS.
Yep.
and then everything else is just very low usage, I guess.
Yeah, they're not going to use really anything at all.
So what should I use for this one, Joe?
What are you talking about?
The resistors?
3 100s in parallel?
Oh,
Is it still too hot?
No, it's not too hot, but it's still hot. Is
Okay.
that okay?
You can use a higher value resistor, which will reduce the total current running through it.
Okay.
The lower the value of the resistor, the more current it'll pass, which means the hotter it gets.
Okay. So 150 maybe?
You can try 150. Yep. 200, 220, 400, 970.
But the more they get, the noisier it becomes.
So the smaller a value resistor, the more current it will pass, which means the faster the fan will spin, which means the noisier.
Oh, really?
Right.
Oh, I thought it was the other way.
I see.
No. The higher the resistance, the more it resists the flow of current, which means less goes through. It's like turning the valve.
All right, let's do 200.
Yep. So 200 is the same as putting 2 100s back to back.
Right.
That's a great idea. The idea of separating the wires so they get the same value out of it without the downside.
Oh yeah, no noise at all.
Mm-hmm.
It's hot.
It's hot. It's still pulling too much current.
Yeah.
So yeah, you're gonna have to, in order to do that, in order to do that safely, and this is also why, how can I put it? This is why fans usually, like in electronic and small electronics, are not controlled by a resistor. They're controlled by pulse width modulation. Too hot?
Yeah.
Yeah. But I won't get into that right now.
Javier, what are you feeling? Like a scalding hot feeling through the quad?
Yeah, it's scalding hot. Yeah.
Yeah, it's just pulling too much current.
Yeah. That's all right. I can get more.
Let's just make the assumption it's pulling 2.8, a maximum of 2.88 watts minus the dissipative value of the resistor. So all of the extra heat, that's all a resistor does, is it takes the energy going through it and irradiates it as heat. It converts it from electricity to useless temperature. Point the fan towards the resistor. No. So you can also think of it, there's
well,
how do I want to term this? Energy can neither be created nor destroyed. It goes.
I was just wondering if that was what you were sort of had.
It goes somewhere.
Yeah.
So if you're taking the energy out of that in the means of current, where's it going? It has to go somewhere. So it's being slowed down by the resistor, and the electrons are being slowed down to the point to where they convert to heat, basically.
Because I guess the default form that the electricity would just switch to is heat, like in the absence of any other thing to switch to.
Exactly. Exactly. Same thing. When you stop your car and you press the brake, where does all the kinetic energy of the car go?
That's a good.
Into the brakes.
The brakes
they get hot. And if you brake too hard, bright red.
Like skid or something. Yeah. Oh, that's interesting.
Yeah. And then you get what's called brake fade, where they stop working as well because the friction doesn't work because they're too hot to take any more energy. So the brakes don't work. Because where's the heat? Where's the energy going? Nowhere. There's nowhere for the energy to go.
Oh.
Science! Anyway.
Joseph, does that mean that the use of fossil fuels, like, you're not, like, on a technical level, like, we're not actually, you can't really use up energy. It's more like we're changing the form of the energy.
Exactly. Where do you think fossil fuels came from?
Well, from animals that, became fossilized and I guess had carbon.
And where do the animals get their energy from?
Well, I guess they got
Food.
plants or whatever it was that they ate, or
Plants. Where do the plants get their energy from?
from the sun.
Sun.
Right?
The sun. So for wow, it's science with Joe time. all of this energy the sun has been imparting upon the earth for hundreds of millions of years got chemically converted from ultraviolet rays and light into bonds, into chemistry, in chemicals that would change their form, and it would hold that energy in those bonds, which it gets converted over time. Animals die, they get compacted. And we take that out of the ground and we burn it, and we're releasing that energy right back out. It's all solar energy, all of it, 100% of it.
And the pollutants in the air, I guess that's not just energy in another form. That's just other byproducts in another form, right? Like the smoke and the right. I mean, that's not just like heat coming off of.
Well, yeah, that's just the byproducts of breaking the chemical bonds and the things that we're burning.
Oh,
yeah. So every time you snap a chemical bond, the molecule goes to a lower energy state, and it releases that energy typically as heat. In the case of like a gasoline, it expands, and that's what pushes pistons down, which then moves the car. But yeah, the particulates that are released aren't what we're really using. It's the energy from those broken bonds. Yeah.
And I guess for whatever reason, scientists can't. I mean, the sense that there's a scarcity of this must mean that we can't artificially make those bonds that have been made over.
We can, but we have to get the energy from somewhere to recreate the bond. Where'd the energy come from billions of years ago? The sun.
Mm-hmm.
So how do we recreate that now? Well, every day at noon at the equator, if you take a square meter of space and measure the amount of energy that hits it from the sun, is 1,000 watts. So if we can take that energy,
what's 1,000 watts?
If you take a 1 meter square area at the equator at noon,
okay,
the amount of energy from the sun that hits that meter is 1,000 watts.
Oh, wow.
That's a lot of power. So if we convert that solar energy into other usable forms, either directly through solar panels, which are only at a maximum about 43% efficient, or by reflecting it with mirrors and boiling water, solar towers, or using updraft, where we create a greenhouse effect where it heats the air and spins air up through a column and spins a turbine, or wind turbines, which are also technically solar because the sun is heating the planet, causing temperature gradients, causing air to move. We can suck that energy.
Wind is really just a couple steps away from what the sun did anyway, or something like the direction.
Yeah. But I mean, like it's a factor of doing it in a way that doesn't use other already chemically bonded stuff the sun made 1 billion years ago.
I see.
Right. That's the trick.
And we know how to do this. I think the biggest bottleneck is like batteries big enough to hold it or something.
Hi, Javier.
Javier?
There's a billion different reasons. It's cost. You've got lobbyists and stuff that are in the fossil fuel industry that are slowly starting to change their minds on it because they see the writing on the wall, but they're reticent to try to change a system that already works for them, because why would they invest cost in another system when they already have a system that works and that basically has got a zero net operating cost because they've got it whittled down to a science, right? Put coal in the plant, burn it, boils water, spins a turbine, repeat. Right? So their interests. Nuclear power, MacFX notes this because he works in nuclear power and knows. Nuclear power is another way to do that, but it has its own a whole bunch of different caveats. Chernobyl and Fukushima come to mind.
Right. In this current
Vesta plant at Toledo that almost exploded 15 years ago that nobody knows about, that it was not really talked about. But we were 3/8 of an inch of a steel cap from that plant exploding. So whatever.
Oh my God. Wait, Joe, is Javier, did he disappear?
He must have disappeared or had some sort of technical issue. So we're just going to sit here and talk and make it sound.
I think it's like the capitalist system, right? Like that, because they work in this quarterly 90-day thing that, you know, where they have, especially if it's a public company, you know, that they're unable to, like, even if you told them you'll make a ton more in 5 years, it's like
There he is.
the system is not set up to do that, right? So it's like if you can't show in 90 days,
yeah, there are layers and layers and layers to
running. Even if you promised Exxon, we'll give you a near monopoly on this thing, and you can make all the money just in alternative energy. They won't do it unless they can do it in 90 days and show an earnings thing, right? Like they won't do anything.
It's all about, well, where's the investment for the money come from and all of that stuff too. And it's also, you stated a point earlier, solar power only works when the sun's up.
Oh, so that's why you need
happens in the middle of the night. Where do we get our electricity from? Where we've got to store it somehow. And there are ways we can do that. None of which are really financially feasible at the moment or ecological. For example, there's a great concept of storing power. So say in the middle of the day, we always have double the actual needed solar capacity. So we have a net unit of 1 solar panel to power our town for the day, but we add another net unit, 1 unit of solar power that runs a turbine. During the day, it runs a turbine and pumps water uphill to a high uphill reservoir. So we're converting solar power to a gravity battery by pushing it away from the planet up to a hill and storing all that energy in water, in the mass of the water as a kinetic battery. And at night,
pushed it up,
switch over to it, and it flows back downhill and spins a generator. And we re-release that energy at near 100% efficiency back out to generate power at night.
That's an amazing thing. But except for what is needed to push it up, is that a fossil fuel that's needed to
no,
get it?
That's why you make net 2 units of solar power. Solar power 1 runs your town during the day. Solar power 2 just sits to the side during the day, and its entire job is to run a pump to send the water uphill.
And somehow, like, the amount of solar energy needed to push it up must be much less than the benefit you get from the kinetic energy coming back down or something.
No, it's the exact same amount. And in a perfect world, energy is neither created nor destroyed. If you push 100 watts of energy up and let it go, you're going to get 100 watts of energy right back out.
Oh, I see. So it's really just a way to delay and store it. It's not that
you're moving
to multiply the effect of that solar thing or something like that.
Converting the solar energy into electricity, which then pushes the water up, that converts it to potential energy. Then when you release it, it converts it to kinetic, spins a turbine that converts it back to electric. And so you do that, and then it dumps back through. So during the day, you're pumping up this kinetic battery, and at night you let it go, and that's what runs the power grid at night. But here's the challenge. Who wants to pay twice as much for their electricity during the day to maybe have power at night? And where are you going to put this gigantic reservoir?
Well, I happen to think of it. I think it's
going to build a mountain that's 25 feet high, or 100 feet high, or 1,000 feet high that's off to the side of the town, whose entire job is to hold a big tank. Like,
I saw this thing on YouTube. I don't know. You may have seen it too, because it seems to fit exactly what you were saying, where they were showing it in Massachusetts, Western Massachusetts, like that there's this mountain that where they dump water into the Connecticut River going south, through Connecticut to the Long Island Sound. Like, and I think they're making the point that, like, that was a sort of unique geographical thing that used to be used for a fossil fuel thing, and they converted. But I think they made your point that to make more of those mountains that would just be very expensive.
Like, I'm in Ohio. It's flat as balls out here. Well, balls aren't flat. You know what I mean? It's flat as crazy out here. So creating a process to create, and this is just one example, creating a process to do a lift system to store that energy. It's an ecological nightmare. Like, you would have to take like an entire county of the state, and its entire purpose is to be a power plant, and nobody wants that. Right? So that's an issue. So what other ways could we store this power? MacFX has a great idea of this. Solar power during the day and nuclear at night. Sure, we can do that as well. But again, nuclear power has all of these issues that I'm not in the nuclear power industry, so I can't say, but there are a lot of how can we put it, safety and long-term ecological issues from the nuclear industry that just have not been solved.
Yep.
Like,
but that at least in theory seems solvable because it doesn't seem to give off
No.
a byproduct like carbon. I mean, there's the safety of just this disaster, of course, but
oh yeah, I mean, and think about it too. When you think about the ecology too. So, like, if a nuclear power plant, something bad happens,
Right.
you've got a 30 to 100 mile radius of the Earth that is uninhabitable ever again for the entire existence of the humans being humans. We will have evolved into a different species by the time we could go back into that spot.
so like Chernobyl and the area around it is like that now. Like, where
Correct.
Chernobyl is uninhabited for the next 15,000 years.
unless we could invent like something that could neutralize it somehow, right? Like some other.
Yeah, that's how radiation is. It is radioactive for thousands and thousands and thousands of years. Even if there's not an emergency, spent fuel from the process, you can reprocess it and get the unused uranium parts out of it, reconcentrate it, mix it in with other mined fuel, and continue to reuse it. But what about all the junk from the splitting those atoms? Polonium-210, cesium, strontium, calcium, all these crazy, both short-term iodine, short-term and long-term radioactive particles that are made from the splitting of those atoms that will continue to split into other stuff and split into other stuff and split into other stuff for tens to hundreds of thousands of years. Where do you put it? You can't put it near anybody.
The kind of meltdown stuff. I mean,
well, yeah, it's the same stuff that happens from a meltdown or explosion, but it happens in the contained reactor. But once that fuel is spent, you got to get that stuff out so you can put fresh fuel that has a higher energy ratio back into it so it continues to be efficient. So you get all that junk out. What do you do with it? Where do you stick it? Bottom of the ocean? Nope, it's going to leak out eventually and kill everything in the ocean. Put it underground? What if somebody 100,000 years from now from a completely successor civilization that doesn't know that's down there mines into it and releases it and kills everybody on the planet?
Oh my God.
That's the problem with nuclear. And it is really, really difficult to
right?
get, how can I say, the political wherewithal to correct the problem. As MacFX is saying, again, he works in the nuclear industry, so he knows more than me. Like, right now, the United States, we have a place to stick this stuff that will be geologically stable for millions of years. We know this. Yeah. It's Yucca Mountain. But there's no funding to get stuff there.
Where is that? I don't even know.
It's in the somewhere. It's way out west, in the middle of nowhere.
Oh.
So, we can shove all that stuff out there, but like there's no political or financial wherewithal to get the stuff out of the nuclear plants and out over to Yucca Mountain. So in the meantime, you have all these wonderful nuclear plants that provide all this like extremely awesome power that emits nothing into the air. It's just power. But on site, you've got hundreds of thousands of tons of nuclear waste in dry casks in these special sealed containers in the open.
Oh, wow.
What happens with that? Is it just going to sit there forever in the open? That stuff, those casks, although they're really good at storing stuff for relatively short periods of time. We're talking 100 years here. They're not designed to just lay out in the open for the next million years.
Mm-hmm.
They need to be stuffed somewhere. So until we get the wherewithal to send it somewhere, it's just gonna sit out there. So that's the big issue with nuclear power, at least in the United States. Europe's kind of got it figured out.
Oh, they do that issue where to store the byproducts.
They have some of their similar problems though. The other thing is the power plant technology itself. The power plant technology in the United States, even though relative to say some of the old Soviet technology, is still insanely secure and insanely safe, there's still problems. Like I mentioned back in the late 90s to early 2000s, the Davis-Bessa plant up by Toledo. They weren't paying attention and a small baric acid, not barium, boric, a small boric acid leak. Boron is used as a nuclear poison in emergencies, but they had this boric acid loop, special pipework that's designed to hold the boric acid. Well, it developed a tiny leak, and it was dripping onto a gigantic steel cap that was holding the coolant pressure of the nuclear containment. We're talking a 6-inch, like 6, 12-inch, 18-inch big. It was like this huge, thick steel cap, right? This boric acid had been dripping on it for a long time.
Oh my God!
Caught it. Even though this was like a Gen 3 super awesome nuclear power plant, that even in the event of like anything you could think of, it would auto scram and be safe. It had whittled that down to this. That cap got whittled down to that.
God.
And it was holding 6,000 pounds of like pressure.
Wow.
And it's not rated to hold. So thank God for U.S. Steel for making really high quality steel for this cap. I'm exaggerating to some extent. And I'm not an expert in all this stuff. But basically, when you have a maintenance issue like that, it doesn't matter how safe the plant is. If it's not maintained properly, you throw that safety out the window. And so those are other issues that we've had at nuclear plants in the United States, is that these tiny little maintenance problems that it's not widespread, but it does happen. A major one like that hasn't happened since the Davis-Bessa one, because the entire nuclear power industry, which you would think would have learned after 3 Mile Island, kind of were like, wow, we need to check things. But still.
And that wasn't publicized like the 3 Mile Island, right? It was just sort of not.
3 Mile Island?
No, the 3 Mile Island was, but what you're describing, that incident,
3 Mile Island.
I don't even know when that was.
3 Mile Island was 1977, somewhere in there. And that was because a pilot-operated relief valve popped open and released the coolant system in a way that it shouldn't have, but a tiny micro switch that was designed to measure it was not designed in the proper way to show the operators the actual value of the valve or something like that.
Oh my God.
Basically, it was just dumping the coolant into the sump. And it boiled dry, basically. And when it boiled dry, it melted. Upside, again, to U.S. nuclear reactors, it melted the entire freaking center of the core out, and it just laid on the bottom, and it did not release anything outside of the containment vessel because it was really, really well designed. But still, we don't want that.
And
right?
That left a radius, just like the can't.
There was little to no radiation that left the premises of the plant at 3 Mile Island. Again, their plants are well designed, but it ruined it ruined 1/4 of that plant. It ruined it. That quarter of that plant is now unusable forever. For the most part. Until I believe decommissioning is done or nearly done, but it's been a 45-year process to very slowly remove the remnants of the reactor and the core materials and all of that stuff incredibly slowly and incredibly painstakingly so that nobody dies to the point where you can get it all out. But I mean, 45 years or whatever to clean up an exploded or a melted nuclear reactor. I mean, what's the cost on that? And again, those are some of the factors that factor into nuclear power not being as powerful as it is. Gosh, this has turned into absolutely nothing about this TransWarp and everything about
No, it's just fascinating.
It's all about energy, man.
Joe, I am. Javier is helping me with this. The Apple II joystick. I found that when I was a kid, I actually got a 2E enhanced it was November of 1986, and I saw they had a GS in the store. But when you're a kid, you're it was just unbearable because I'd wanted this thing for so long. So I wound up getting the 2E. But what I later found was that the joystick I had was actually a platinum one. It never even occurred to me that what would be in January of '87, like the platinum 2. But this is the weird thing I was telling Javier is that whenever I would, except in like 3 cases over the years where I've managed to get these hybrid ones, I found the ones that have you don't need the screwdriver, like that are normally associated with the gray button, non-orange button one, like they don't have all 9 pins. And when I try to use them on multiple machines, like not just the 2E, I tried on 2C. I think it's like you can only move horizontal and not vertical. So it's like, and nobody seems to know what I'm talking about. So my only solution has been to just look on eBay till I could finally find like a few platinum gray ones that had the old Phillips head requiring or whatever it was. Does that make sense? Why does nobody else have this experience?
That's weird, because all the ones that I have that are missing pins, they work because they just pick out the pins, but they don't. Yeah.
I have no input on that because the first joystick for an Apple II I ever touched in my entire life was at Kansas Fest 2019.
So you just
exactly one. It's still in the box and is right back there. So I don't know. Mine just works.
I did not figure it out. So I sent Javier the first one I got in '86. That's the only machine I have that like I've had since it was literally new. And it had, what it had? It had the 2 RAM chips that I remember the guy in the store saying, "Oh, they're always remodeled. They're always improving on the 2Es. Like they just reduced this to 2 RAM." And I had this visual memory from 1986 of him showing me those 2 chips that are now the, I think, biggest difference between the older board and the newer one, even though there's like a million variations, I guess. The
later 2E with the only 2 RAM chips is sometimes called the Platinum 2E board, even though they were in non-platinum machines for a period of time. So it's
probably right at the tail end, right, of the enhanced. If January '87 was going to be sort of like a hybrid in a way, or I don't know, something like that.
Well, I'm showing right now
his collection of joysticks.
Look at this.
Well, no, these are his joysticks. These are Jeremy's joysticks.
You're showing off Jeremy's joysticks to make me jealous.
And then this is a CH Mac 3 original one, and it only has a certain amount of pins, the ones that the computer uses, so it doesn't affect anything.
Oh yeah. So yours, they don't put all 9 in those.
No.
They don't need them.
Spots, right?
They don't need them.
And yet you don't. You just adjust the things on the bottom, and you are able to navigate just a simple game. And it does, for me, it just won't. Even though I've tried it on multiple different computers, it just.
Well, maybe you had a little issue, and then you assumed that it was in all the computers or on the joysticks, and because they all work.
Maybe it was the version of Pac-Man I was trying. I don't know.
Maybe, yeah, exactly. Maybe you had an issue, or maybe your connector was having issues, something like that, and it made
you didn't yell at it loud enough.
Hey, talking about that, look, Jeremy also sent me this machine, and I want
you have to show Joe this thing.
This is like this because I'm about to retrobrite it. I took out the Apple logo.
Oh,
but
wow.
I am having issues with this. Look at this.
Oh, how do you retrobrite that?
Exactly. How do I retrobrite these guys?
Jeez.
So I will, but they may be like I'm gonna have to do something about this because I gotta put paper.
Two processes for you, sir.
What?
I have 2 potential processes for you. Both require very, very careful, meticulous work. How are you with a paintbrush?
Oh yeah, I'm very good.
Painting. Like I trust him with this. Is like my most prized thing in the world. Like
I know.
I got this idea to ask Woz to I literally put masking tape to try not to be rude to him, but to have him do it literally right above to
Yeah.
Yeah, I'm either gonna I'm actually gonna mask it, but look at this.
Mask it.
I gotta put on top of the masking tape. I'm gonna have to put some kind of tape or some kind of plastic, so the tape, the sticky part doesn't touch the Woz text.
Yeah.
I
have a
really good at not wearing off the silk screen thing, which I find can easily wear off just with your fingers.
No, the silk screen is okay.
Oh,
but
it is?
This, I don't want to even touch it.
Oh.
This is marker Sharpie or whatever it is, but I don't want to affect it at all. So I'm gonna retrowrite everything, and then maybe later I'll see what I can do in that part very close. But that's
I have a potential solution for you, Javier.
okay. I'm all
If you
ears.
take a perfectly clear lacquer that is ultraviolet, like an ultraviolet protective lacquer.
Yep.
And very, very careful with a tiny brush. You may be able to literally paint directly over the black parts of the writing.
That's not a bad idea.
And then retrobrite it normally. Because what will happen is, the lacquer will protect the ink,
Yep,
both the peroxide and the UV.
I got a masking fluid that I sometimes use, but and it's good. It protects things, but it is not very reliable. Meaning, when I retrowrite things, sometimes it peels at the end of the retrowrite.
Gotcha. Okay.
So no, yeah. So yeah, your idea is a lot better. Yeah,
you don't want to retrowrite. In other words, you put that the masking thing over it.
Yeah. So I may do double thing, like what Joe is saying.
Yeah, Eric Rangel. I can never pronounce your name, Eric. Nail polish.
Yeah, nail polish.
That's another thing.
I could actually put nail polish. Yeah, that's easy.
You could overpaint it.
Yeah.
With a black enamel or something that's really tough, very, very carefully, so that you're just covering over the original. Yeah.
Yeah, I got very good brushes.
Yeah.
Specific for very thin work, so I don't have a problem with that, and my hand is pretty good at that.
Like that.
But yeah.
Oh wow! Is that a tiny paintbrush or is it tiny?
Yep. I use this in combination with my what is this damn thing? Microscope to paint on. I'm getting an echo. To paint on what is this stuff? Ultraviolet curing solder mask.
Oh, okay.
Oh, really?
And I just use this insanely. I mean, look at how tiny that thing is.
That's amazing.
Well, I got these ones. Yeah, they're not as tiny as yours, but yeah, I got this small.
Mine's smaller than yours is.
Joe, how did you find that? Was it part of a set of computer tools or something?
No, it's just a tiny paintbrush.
Oh.
Yeah.
It's just a paintbrush. There's nothing fancy about it. I just went and
there's brushes that they're very, very tiny for painting. Yeah, for oil painting.
And they're used for doing really fine detail work.
Yeah.
Just that's really all you need.
Yeah, I should have some of those too. You're right.
I mean, if you need to get even finer than that, you can use a whittled down a piece of wood or something like that to get super, super fine detail. But
yeah, I got some, but yeah, there's not as small as the one that you got. But yeah,
is that? Wow.
But yeah, that's a great idea. I'm gonna put something on top of it, so it covers it, and then I'll still be careful.
Yeah, if you think it's too dangerous, you're just so good at this. I feel like if anybody could do it.
No, I can do it. It's a challenge, and I'm gonna tape it
And I also sent you other case tops in case we wanted to use a different, because I think it was sort of Scratch the Apple logo. So I sent you other ones, just
I already fixed yours. I already fixed your logo. So yeah, the logo it's good.
Oh, oh, cool.
But yeah, you're gonna have a beautiful machine. But yeah, I gotta be careful, very careful. So this is very, as you can see, it's a big challenge for me.
Oh,
yep.
Painters touches the machine or something,
I didn't hear the last thing. Can you repeat it?
Oh, I use that thing of using the blue painter's tape, on the first level of bubble wrap that touches the plastic or something. You're saying that.
Oh yeah, that's painter's tape. Yeah.
Yeah, and then after that I switched to mask.
Yeah.
But
yeah, and
I spent hours bubble wrapping these things for you because I wanted.
Yeah, I saw that. Yeah, man, it was very well wrapped. Yeah, that's another thing. I should show what you did because people should begin to do that kind of packing, so they can protect things very well.
You did such an amazing job with the monitor where you showed special corners you got from the dollar store, like all these different things. And I just tried to use brute force of just enough bubble wrap to kind of make up for it. But I don't know.
Oh, John, that's good. The 00 paintbrush sets. I'm gonna do that. You're right.
So Javier, so the things that you've sent back, like, so what's the best thing to store? Because I don't want them to ever get re-yellowed again. Like, so
well, then you're gonna have to airtight it. Put it in a airtight bag, and then put it somewhere that doesn't get any light or temperature.
Oh,
yeah, unfortunately, that's the only way that you will be able to preserve it without changing color again.
But if you just set it up somewhere where it just doesn't ever get any direct sunlight. I mean,
no, it's not only the direct sun; it's also the temperature, and also the quality of air that you have. So
I'm sorry, you're saying the temperature in the air. You said in the house?
Yeah.
So right now I have it wrapped in like blue static proof bubble wrap, but I was thinking that's probably not going to do anything to protect it from this.
No, because I actually I did this test also a few years ago. I put my Apple IIcs inside some bags and kind of airtight them and put them in somewhere really closed. Mm-hmm. And I still, like a year later, I opened them up and they were a little bit humid in the inside. I don't know how they kept the humidity, and it was kind of wet. So that was really weird.
You also live in Miami where it rains every day.
Well, yeah, but I pack it in an airtight bag, so that was supposed to be not even humid, and they still get a little bit yellow. So you got to do it.
Humidity, which you could wipe off, it's still left residue of yellow or something.
Yeah. So
basically, but I guess the machines that yellow really have had time in the sun. I think something you really keep out of the sun. I mean, almost totally.
Well, it's two things. It's you gotta have the what kind of plastic you have. Some plastics, some batches of plastic were better than the other ones, and that's where you get some plastics. Sometimes some Apple IIs don't really get yellowed because either they were in a
car is like twice as yellow as the rest of the keys.
Yeah, exactly, or they were in a nice environment.
Mm-hmm.
Or they, also the quality of the plastic helped a little bit. So those are the two things that may work.
And maybe Joe too, really seemed to care about the.
You're cutting yourself.
Oh, no! I mean, some people, I think, collectors don't really care as much about the external condition.
Yeah.
Like you and I just seem to care a lot about that, but some people
they say patina. Yeah. So I mean, it's what it is. What it is.
In my case, it's a factor of laziness.
Yeah. Well, I like to use things.
I have to retrobrite it 5 years again.
Yeah, I love to retrobrite.
5 years ago, man, and then to do it for 5 years. Yeah, I just no.
So, Joe, you sometimes do retrobrite, but
I have done a couple retrobrites. My results have been less than satisfactory. And I have not done them again. I will see if I can show you real quick one of the last retrobrites I ever did. So you talk amongst yourselves while I fetch it out here.
Okay. So Javier, Javier, I put in the mail to you today that the expander thing. I know
you see, guys, he has a very rare expander card from. Oh,
cool. Commodore 64. Yeah, wow.
Look at the nastiness. Look at the chunkiness.
Oh, that was from painting the retrobrite or something.
That's what the retrobrite did.
Oh,
yeah. Either it was too strong, or you put it in a bag, or you wrap it.
What's that?
Did you wrap it?
This was immersion.
Oh, then it was very strong.
Yeah. And what happened as well, you can kind of see there's a shadow. There's a little bit of a shadow right here.
Yep.
Because this plastic was lighter than or less dense than water, it floated. So I had to go down, and then the weighted part kept both the light and the peroxide from reaching it. So there's a permanent shadow there that you can never get out.
Oh boy.
So yeah. So I started here. To try to, it's kind of hard to see. I can't see on my screen what I've got. A second screen I can look at. What am I doing? So right in this area right here, it's a little shinier and it looks a little bit better. I polished that area.
Okay.
It came out nice. So my thought was I will eventually polish this. That was 2.5 years ago, and nothing's happened. So
you mean in the middle of the retrofit process, you polished it or something? Like
No. At the end,
after I ruined the plastic.
Yeah.
The machine works great. Perfect. It's just
Javier. So that monitor, like I bought from that guy, like I know he randomly put in that fingerprint card that I never even opened the box, but he probably but that monitor I thought was in really good condition. That was why I like tried to get it from him. But there was that one little thing at the top of it that I thought maybe you could fill in a little material or something. But
I'll check it. I just retrowrite it, so it looks very nice now.
Yeah, I tried to get you one that was as good as possible. But as you were saying, a lot of people don't even use the. Like Joe, do you like to use the CRT thing anymore, or you don't even use it? Like, stuff?
I usually don't use CRTs anymore.
Yeah.
With a few exceptions, one being my Pumpkintosh. Still using the
which is this? Which Macintosh?
Yes. I call it the Pumpkintosh. It has a Mac Effects clear case with orange LED strips in it that look like neon.
Wow.
And I swapped it out with an orange CRT. So it's a pumpkin.
That's so cool.
So I use that. I use this all the time. This is the machine I test all of the blue scuzzies I make for shipping. Yep.
Is that an SE or something?
Yep. That is an SE30 with 64 megabytes of RAM, and it's got a big mess of wires, Raminator 2 in it. Yep. It's got a working floppy drive. Maybe.
The work.
Yep. Yeah. This is what I use this to test all blue scuzzies. Every blue scuzzy I sell gets tested before it goes out.
Nice.
And Joe, by the time of the SE, they changed over to Waz's ADB, like in those Macs, and like even though it was in like the late '80s, I think, like they'd switched over from whatever that other standard was for keyboards and stuff to the ADB.
Oh yeah, the
round,
ADB, which was originally
by that machine.
Which was the front desk bus, which then got its name changed to the desktop bus. That was the first machine that actually ever had it. Was the Apple II GS. Yep. And then the SE in that series ended up getting it later. Not much later, but yeah.
Yeah, I looked this up. There's like, I don't know, like maybe 10 different variations of like the ADB mouse 1 or whatever, like.
Oh yeah. They're all pretty much the same. They all do the same thing, but yeah.
But Javier does an amazing. I don't know if he's ever done things for you, but he's just an amazing job with this retrofit.
Javier does lots of things for me.
I try, yeah.
Is he explodes computers and sends them to me to fix?
Oh yeah.
Okay, I remember you said you were sending Joe something about a disk 2 drive that didn't make sense to you that he was take a look at or something. And I remember it was a funny video where you had a Lego airplane like flying to Joe.
So yeah, that was good. That was great.
Yeah, it was bad capacitors. I think we saw.
Yeah.
That's your sound chip, Javier.
And oh, nice.
That I found out because of the green dot on it actually works.
Oh.
I used the broken sound chip. It's all piled up on my bench here, actually. I used the busted sound chip from your LC2 board to test the sound on this classic 2 board, and it still doesn't work.
Oh boy! Wow, that's a real weird problem. Yeah.
Yeah. I have these 2 classic 2s that I got that were basically pristine. One of them was in box. It was taken out, turned on once, turned off, and put back in the box. And it's the one that ended up having the least corrosion. And I had another one that came with it that had been used a little bit more, but it had standard capacitor junk and all that.
Oh my God.
Fixed them both up. They both work perfectly, with the exception of neither has sound.
Oh boy.
Even after recap, even after replacing the sound chips, even after replacing the sound amps with brand new sound amps.
Wow.
no sound. And by no sound, what I mean is they have sound, with the exception of one of them has sound that is insanely muffled, and you can only hear if you plug it into external speakers and turn the speakers up to 11.
Oh my God.
And then it sounds okay. It's just muffled. And the other one will only make sound if you take a hot air gun and blow it on the Eagle chip, which is the generic glue chip, which means that board has a bad Eagle chip.
Oh boy.
Yeah.
Oh, so you did isolate what the problems are then with at least one of the two, or like at least.
Yep. So it's which one is it? I believe yes, it's this board here. So this board here that doesn't have the sound chip on it. It's what just fell? Oh, the chips.
Oh boy.
They're still on the bench somewhere, whatever. So this board here that has the sound chip missing off of it. This here is called the Eagle chip.
Okay.
Right? This is it's a generic logic chip that replaces the 15 different logic chips on an original Mac. It can do.
Oh wow.
Like the Mega 2 and the Apple II GS. It does the same. This chip, if it's cold, causes
So weird.
the sound chip to what's called motorboat. It goes, and the speakers will make this popping noise until the chip heats up. Once the chip heats up, this one that has nothing to do with sound, other than being the connection between the rest of the bus and sound. Once this heats up, the motorboating stops, but the audio is still quiet.
Wow.
It still was placed correctly then. That's so strange.
Yeah, so like I can take, this is why it's on the bench, I can take a can of air upside down, cool this chip off, and it'll start motorboating again.
Wow.
With two different sound chips and two different audio amps. So it has to be this chip. It has to be. Also, this right here, this is the transistor that feeds the mic circuit into the sound chip. I removed that to completely isolate the entire microphone circuit from it to eliminate that as a variable. Still does it with that removed.
Oh wow.
So it's this chip. This chip is throwing noise at the sound chip and making it do stuff.
So, like through trial and error, you realize it was that other chip that has nothing to do with the sound.
Yeah, I just, at a certain point, well, part of it is I have the schematic for the board, so I can tell what connects to the sound chip to tell the sound chip what to do. There's only two other chips that connect to the board that tell the sound chip what to do. One is the egret chip, which is a microcontroller that controls ADB and about 100 different things on the board. And then the other is the Eagle chip, which is a generic logic unit, which handles 100 other things on the board. Those two chips are the only two pieces of logic that send data, and information to the sound chip to tell the sound chip what to do. So I started messing with those two chips. And I just screw around. I short pins together carefully, mind you. Remove and resolder the chips. I check all the traces around the chips. I check voltages on the chips. I probe the interconnects between the two chips with a oscilloscope to see if the sound waveform data is making it through. I use a multimeter to check the points between the actual pins on the two chips to make sure the trace all the way across the board is connected. Just stuff. And then once all that checks out, then I just start doing wacky stuff like spraying cold air on it, or with my hot air gun, hot air on it to see if it changes the function, to see if there's something funky with the chip itself.
I know.
And that's how I found
I don't think I've ever seen a hot air gun, but it's sort of a similar, I guess it's not a can, but it's something.
If I can get it.
Yep.
So,
Javier, do you ever use hot air?
Yeah.
Oh wow. So
that's how you remove the surface mount chips. You heat up all the solder until it all melts, and then you.
Really heating? Oh, I see what you mean. Like super.
Yeah, 450 degrees Celsius.
Yep.
Like 100 degrees
Really
Fahrenheit.
hot. Yep.
Yeah, like pointed at your face and your eyeballs will melt.
Yeah, they will burn.
Yeah.
Wow.
Mm-hmm. And so I turned it way down. I turned it down to like 120 Celsius, just above boiling, just not like super hot, just to warm the chip up. And you warm the chip up and the motorboating stops and the sound's there. It's just muffled and I got to turn it up to 11. So it makes me think that I have three bad, the actual sound chips are bad.
Mm-hmm.
Because again, Javier, I took the sound chip out of your LC that wasn't making sound and put it in this, and it has the same muffled sound problem. So I think
Oh,
I have
wow.
3 bad actual sound chips.
Jeez.
And in the case of this one, I have a bad Eagle, which I can't. There is no way in hell I'm going to get a replacement Eagle chip.
Oh boy. Yeah. Yeah.
Wow.
It's more rare than the sound chip is. It was only ever used on this machine.
So we need to get.
I'm getting another good board, which means then this is just a bad board, which is parts to fix somebody else's board.
Jeez.
So the LC, so the two that you were using interchangeably were Javier's LC2 and
Yeah, so the sound chip on the LC2 and the sound chip on the Classic 2 and on a lot of the lower cost machines are the exact same chip. It's the 344S1033, which is that chip right there. And they're all the same chip. It's just it's a stereo sound chip. It's digitally filtered audio chip, DFAC. And so if you've got another working machine, you can just yank the chip off of it, throw it on the other board, and it works.
Wow.
wow.
We're gonna have to look for one. Another donor board.
Yep.
Oh, so Javier sent that in as
Well, but I ended up shipping it to you, Javier.
Yeah. Oh, and that's another thing that I got from Jeremy. He has a fast SCSI drive card.
Oh, cool.
Oh, good. Well, you got that. Oh, cool.
Yep. So I'm gonna test it also when
here? Like I wasn't sure if it was too many cards to fit, or if we could fit them in.
we can fit it. We can fit it. Yeah. But yeah, not too many more. Because yeah, the TransWarp is gonna be here, and then I think a little bit too much. And I'm gonna have to put some separator, something like pieces of something to separate the cards and they don't touch each other.
Oh, what could you use for something? I guess
I'm just gonna use this. Maybe. Oh, you know what? The feet, those feet for the drives.
Oh yeah.
Those are good. Yeah. Because somebody put a transparent feet over here in yours. So yeah, that's a good idea. I'm gonna put it whenever I can.
Someone put transparent feet?
Yeah, there's a feet over here. Look, you see it?
Javier, I blame you.
Oh, wait,
Yeah,
it cut
no,
out
I
for a
didn't do
second.
this.
I can't see the video right now. But
Okay, well, there's
oh,
one.
oh, wow. Oh, it's on the Ethernet card. Oh, I
Yep.
see.
So that's a good idea. I'm gonna do that.
Javier, is it possible that the 2 meg expander?
Oh my god,
What's that? Red battery?
that's a killer.
Yeah.
That's what a killer of boards.
Yeah, I removed that from the Color Classics.
Yeah, those are dangerous.
Is that the same battery that you'd put in a 2GS or something? I mean,
Yep.
Same.
Look what I got. Barta.
Oh, that's that special one that seemed to have, that I sent you or something that like.
No, I haven't
something
opened the one that you sent me. This is one that I removed from one machine once. Yeah,
Oh.
this is killer. This is motherboard killer. Yeah.
Yeah, I don't know if some have better specs than others, or if it just doesn't matter for what
Yeah, the modern ones are good. You know, I got new ones around here. Let me look.
But like always, with any of those batteries, you're taking the machine out. If you're putting it in storage and not using it for any more,
Yeah, you gotta take it out. But yeah, I got new ones here.
the
I got
battery,
these ones.
they randomly explode for no
Tyrode.
reason at all, and they will destroy your
This is an old
machine,
one.
and you will have a sad time.
we're like there's like battery acid all under it or around.
Oh, yeah.
it. Like,
It's alkaline, but yeah, it's basically potassium hydroxide.
Yeah.
Lithium hydroxide. Yeah, it just destroys everything.
Yep.
I always remember it being the purple and green battery. I guess it's hands and it's an Israeli battery. From when we were younger, like that seemed to be the one that was always used.
Yeah, there's the I think Maxell is the worst one. Which one is the worst one, Joe?
I think Maxells are the worst.
Yeah,
thing.
Maxell.
But they all have the problem.
Yeah.
I mean, the Vardas tend to be better.
Yeah.
One of the sound chips is missing, Javier. It disappeared on my bench, and now I'm pissed.
Huh.
Oh no!
I mean, it's a bad sound chip, but like, I want it back.
But still.
Oh god!
Yeah, you got a blue one. Yeah, I think what's gonna happen, I'm gonna have to do a second program, maybe tomorrow,
Sure.
to test this.
So I didn't hear. But you thought of like, oh, you could use those little bumpers between the cards that tend to kind of fall together.
Yeah. So they don't touch each other because look, they're touching.
And Javier, what's going to happen when we try to put the 2 meg? Is that going to fit on the back, or it looked like it might fit on the back? There seem to be some holes.
Yeah, there's a port here.
Joe, Javier, this like really thing I happened to come across, like this 2 meg expander for that brings it up to 8 megabytes.
Yeah. So I don't know if it goes here or it goes here.
Yeah, Joe, do you know where it would go? Do you think?
I don't know. I gotta check it. I still, again, I haven't.
Yeah, that's just gonna go in the. It's gonna go in the slot there. Yeah, it goes in the memory slot.
Yeah.
Because on the back or the teeth on the front, or
there's one here on the front.
There's something on the front, and then there was something else on the back.
There was there's on the back.
Oh, okay.
Did you send me that memory already, or?
Yeah, today I literally put it in.
Oh, you put it today. Okay, good.
I wanted you to be able to have the fun of opening it, because it's still kind of in that
cool
kind of pre-cut.
Great. So I'll show it when it arrives. I'll make another program so we can.
Yeah, Joe, I was so lucky to find that, like, because I'd always seen it in the applied engineering thing, but I never saw like a single one listed.
Yeah, I never seen one, so yeah, that's pretty rare.
Yeah, like so. I've was good. Was also wondering about that thing.
Yep.
This is really exciting. So for the first time, I can actually use the.
Oh yeah, and I already added GSOS in the car in your card.
Oh, thank you. Oh my God, thanks so much.
So and I put a little in it so you can see the speed of the TransWarp. So cool. we'll test it maybe tomorrow when I put the card.
Oh, cool.
And everything is set. So we will do that.
Wow, thanks so. That's amazing.
We're gonna do like Joe, just play.
Yeah, if you ever need any proof that this process works, just look at my machine, cranking 15 frames per second or higher. I don't know what it is.
Beautiful.
On Wolfenstein 3D.
Yep.
Whereas before, it couldn't even run the program.
And wait, how much? And that's going at 17 megahertz or something?
Yep.
Oh wow.
Used to max out at about 13 and a half, and now it's
17.
Yep.
I'm thinking I'm tempted to try the 18 again on mine.
Running just in the background, just like doing its thing, as stable as can be.
Nice.
Yeah, it looks like a modern video game thing, like the way it's moving. So
of course, yeah, because it's really smooth with the 16 megahertz.
Mm-hmm.
That's what people use to test the TransWarps, because that's the only program that really makes use of the whole thing, isn't it?
Games, yeah.
Although I'm tempted to also try the new ones from Antoine. The what's the name of this one? Space Ace.
Squeezer or something like that.
Yeah, Space Ace. I think it's also gonna use a lot of.
Properly programmed games know how to understand the speed of the system. They use a timer-based.
Oh, that's interesting.
They use a timer-based loop instead of a just a tight, well-defined loop. If that makes sense.
Mm-hmm.
They execute the code on a regular timer. So every 1,000 milliseconds, we'll just say as an example, it actually checks and runs code. That way, it doesn't matter what the speed of the CPU is. It runs reliably. It just runs better. That's why, like back in the DOS days, you had the turbo button to turn the turbo off to make games work, because the games back then were hard coded to work for a machine that was 4 megahertz, and if you upscaled it to 8, they ran too fast. Or you got like Choplifter, where if you run Choplifter on a fast chip, you can't play it because Choplifter is designed to always assume the machine's running 1 megahertz.
Oh, that's interesting. Javier, yeah, like when I've tried on a 2C plus in the 4 meg, like sometimes games are unplayable. They're so fast.
Of course.
The 4 megahertz. Yeah, so I've seen that sort of thing. Like,
yeah.
Rudy asked.
Oh yeah, Joe. Javier and I were wondering, like, if with that mocking more C card, if you're using it in a 2C, not a 2C plus that does have the 3.5 millimeter jack, would it be possible to not drill a hole and just like route it through that or something to external speakers?
In what, to use the built-in jack on the machine itself?
Yeah, like couldn't you just loop in the Mockingbird? Like assuming you're going to use just external little speakers,
You
like
probably could do something.
we were
Yeah,
wondering about that if
probably.
you go into it, or if you know, like
Rudy has a question for me. He says, "Did I do an ultrasonic clean on those boards on the two classic 2 boards?" Yes, I did. They did not have sound. I recapped them. They still didn't have sound. I ultrasonic them. They still did not have sound. I yanked and added a bunch of chips and got both of them to start sort of making sound, but only in very certain circumstances.
oh.
So yeah, that answers his question. I believe all of the actual sound chips are bad, and in the case of the Eagle chip, the Eagle custom glue chip is bad as well. Again, because of motor buttons.
Oh, Javier, you're showing a 2C that like with a Mockingbird to show like
Yeah, this is a 2C Plus with a Mockingbird 2C Plus. So
2C Plus doesn't have like a pre-drilled, right?
no,
So
no. So yeah, you gotta make some kind of space or something to take out the sound. Maybe you can use
Yep.
Yeah, maybe you can use the back vents to do. There's like a hole over here, but this is for the security. But maybe you can use that hole to put something through here. And actually, look, there's somebody did this. They designed this little thing to put like a switch in the back. But this is a plus, so it doesn't work here.
Oh.
But we can maybe design something to put some kind of connector over here, and maybe an external thing, so we can use we can put like a connector over there for external speakers.
That would be really cool, because you love the 2C. I it makes me more interested in it. I guess like the different cards for it, you have to choose between one or the other, because I guess there's really only one.
Yep.
Socket, whether you have to choose between a Mockingbird or RAM or whatever.
Exactly. Yeah. Either you want RAM or Mockingbird, because there's nothing.
Yeah, I thought were those the only things that you? Yeah, I guess they are.
Yeah.
There's also the zip accelerator chip, right? But that would go.
Yeah, but it doesn't work with a 2C Plus.
Well, 2C Plus basically has its own.
Okay.
It already has like
Yeah.
And then the ROM for
Sean. Hey, Sean. So yeah, we're showing the. I already did, Sean. Just for you to know, I already did the TWGS card. I added all the.
It looks amazing! Wow.
Yeah, they look good, isn't it? So I'm just gonna wait until it cures, it gets dried, and then tomorrow I'm gonna test it. So that's where we are right now, and unfortunately I'm not gonna be able to show it up today. So we were just talking about other things, and I show the Apple IIc Plus. Give me the eyes, boy. And I'm gonna work on this one too this weekend, because I've been trying. This is somebody loaned me this one, and I need to test it. So because his
guy wasn't working either.
It works with the I don't know where it is, but the ROM, I gotta put the ROM XC Plus in here.
So you can use that and the Mockingbird. Like it's not one or the other for that thing.
I think you can use it. I don't remember now, but yeah, I think the ROM 2C Plus is in here already. So I gotta just check. But anyway, I'll do that later, because we're getting a little bit. Oh, it's gonna be 10 o'clock. So yeah, let's just stop it right now.
Okay.
Just say thank you to Joe to cope with me and my craziness. Thank you, Joe.
And
thank you to Jeremy.
I got enough crazy to go around, guys, so it's fine.
Yeah. So, well, Jeremy, thanks a lot also. And I cannot see everybody, but
oh, thank you so much. So yeah, if you want to meet again when the thing is dry to talk a little bit about it or something, we can.
Yep. I'll check it, and then I'll set up another meeting with you guys, and we'll do a second one. All right. All right. So thanks, everybody.
Okay, I had a great time. Thanks a lot, guys.
Take care, guys.
Okay, you too. Bye, guys.
Everybody wait for 20 seconds while he clicks the buy button.
Bye now.
Bye, guys.